This video is going to be over properties of logs. We have 4 different properties, so here they are. Go ahead and write them down, pause the video. So if you are adding and you want to condense down to one single log, you end up taking the numbers and you multiply them together. If you are subtracting, you take the two numbers and you divide. First number divided by the second number. Okay, this next one, it usually goes back and forth. It kind of just depends. If you have a number as an exponent, you can drop it out in front. Get n times the log of a, or vice versa. If you have a number out in front, you can bring it and make it the exponent of a, so log of a to the n power. Kind of just depends on the question you're asked. And then this next one, log or b to the log base b of x. If the base matches the base of the log, they cancel out. You're just left with x as the answer. Same goes here. Log base of b, they cancel each other out. You're just left with the exponent. X is your answer. So we're just going to work on solving these and simplifying if we can simplify. Okay. So we have question 1, log base 3 of x plus log base 3 of 4. My bases are the same, which they have to be. They're both 3, and I notice I'm adding. I want to condense it down to one single log, so I write log with my base. I take my two numbers, x times 4, so I get log base 3 of 4x. Because I have a variable x, I cannot type this into the calculator. I cannot keep simplifying, meaning I can not get just one answer. So number 2, log base 2 of 16 plus log base 2 of 4. Again, my bases are the same. I'm adding. I want to condense it down to one single log. So I take 16, I multiply it by 4. That gives me log base 2. 16 times 4 is 64. This is something I can type into the calculator, but I have to remember to do change of base. Log of the number divided by log of the base. I type it into my handy dandy calculator. Log of 64 divided by log of 2. I get 6. So when there's just numbers, you simplify completely. When there's a variable, you have to stop. So this was the first property. Looking at the next one, this is going over the second property. Again, my bases are the same. I'm subtracting now, so now I will divide. So log base 2, I have 10 divided by 5. I simplify, log base 2, 10 divided by 5 is 2. Change of base, log of the number divided by log of the base. If you notice that those are exactly the same, and you get 1, cool. If not, type it in the calculator. This is also part of the inverse property, but I'll wait to talk about that. Number 2, log base 5 of y minus log base 5 of 2. Again, my bases are the same. I'm subtracting, so I write log in my base. I'm condensing it down to one single log. First number divided by the second number. Because I have a variable left over, I'm done. That's my answer. Again, if you need to pause the video at any time to write, please pause it. Looking at this one, this is going to be that power property. So this first one, I have this 3. I want to move it out in front. 3 times log base 2 of x. Because I have an x right there, I am not able to type it into the calculator. This next one, the natural log of 5 to the 4th power, I take 4, I bring it out in front, natural log of 5. And now I need to evaluate because I do not have any variables. So the natural log of 5 times 4, let's round to 2 decimal places. And when we do that, we get 6.44. I said 2 decimal places, so that would be our final answer. If you did the natural log and you took 5 to the 4th power, you would get 625. If you did that times the natural log, you would get the same exact thing, 6.44. So it really doesn't matter the order that you do it in, as long as you understand the properties. Properties are going to be used a lot for solving, so we need to understand them to help us solve. The last one, this inverse property, if the base of the exponential matches the base of the log, they cancel each other out. So again, if I have a base of an exponential raised to a power of a log where that log's base is b, they cancel each other out. I'm left with x. Or if it's in log form with the base b and its number is b to a power, it cancels out if they're the same, and I'm just left with the x. So looking at number 1, I have 4 to the power of log base 4 of x. Notice the base of the exponential, the base of the log are exactly the same. They cancel each other out. I'm left with x as an answer. Looking at number 2, 10 to the log of 8. Remember, when there is no base written, it is a base 10, which means the bases match. Cancel out. 8 is the answer. Okay, the natural log of e to the 56t power. Well, the base of the natural log is e. The base of the exponential is e. They cancel each other out. I'm left with 56t. And last but not least, e to the natural log power of 3x. Again, they match. They're the same. They cancel out. 3x is my answer. So this video is over properties of logs.